In this video, I'm going to derive the formula for 5 choose 3. All right, now 5 choose 3, right? That's the number of 3-element subsets of a set with 5 elements. So I guess we're going to need a set with 5 elements. So let's say A, B, C, D, E. All right, so first we're going to have, so over here, we're going to have, this is going to be the set of all 3 permutations. 3 permutations of that set. So first we're going to let's write out some 3 permutations of that set. So I'm not going to write out all of the 3 permutations of this set because there's lots of 3 permutations of this set, right? How many of them are there? How many 3 permutations of this set are there, right? If you think about it, you could say, well, if there's going to be length 3, you're going to have 3 positions. There's going to be 3 positions. And there's no repeats. So in the first position, you have 5 choices, either A, B, C, D, or E. Once you've chosen one of those, then you have 4 choices. Once you've chosen one of those, then you have 3 choices. Let's see, that's 5 times 4 is 20. So there's 60 different, right? There's 60 things in here. 60 things here in the set of all 3 permutations of the set A, B, C, D, E. So there's 60 things here. So I can't possibly write them all out. It'd take me forever. And it would make my arm hurt. So I'm not going to write them all out. I'm just going to write some of them out and then do the ... thing to indicate that there's way more of them in there. All right, so let me just write out, let's do A, B, C, A, C, B, B, A, C, B, C, A, C, B, A, C, A, B. All right, so there's some of them. And remember, the ... means that there's many more, right? We established there were 60 of them. Okay, so now I don't want to say how many 3-element subsets there are. Because that's the point, we're going to count those. So 3 subsets. Now, thinking of the map that I talked about before, we could think of the rule being something like x, oops, no comma, right? X, y, z gets sent over to the set x, y, z. Okay, so each of these are, so our function sends each of these over to the set A, B, C. And again, there's many more 3-element subsets of the set A, B, C, D, E over here. I just can't possibly list all of them out. There's just way too many of them. But you can see right away, right, that there's got to be less over here than there is over here, right? Because we have a collapsing map here. Okay, so but whatever it is, right, the number of things over here, right, how many things are there in the 3 subsets, right? This is the number of 3-element So the number of things in this set here, this is the number of 3-element subsets of a set with 5 elements. So however many things there are over there, right? However many of them there are, another notation for the number or amount of 3-element subsets of a set with 5 elements is 5 choose 3. So 5 choose 3 is equal to, now we can, let's name this P again. Let's call this P. We could call this S over here if we wanted to again, that's fine. But I won't really need it. 5 choose 3, I guess I'll say cardinality of S, right? That's going to be, let's see, how many different things come over to one, how many different things in P come over to one thing in S? We can see here that from this example, we have 1, 2, 3, 4, 5, 6. So that's going to be 1/6 of P. Now let's see, that's 1/6. Now how many things are in P, right? There's a formula for that. Remember, this is 5 factorial over 5 minus 3 factorial. Now let's think about this 6 here. Now why is this a 6? Why is that a 6? Well, the one reason, the obvious reason, is that you look over there and there's obviously 6 things that come over to the set containing A, B, C. But another reason is you think to yourself, how many things in P will come over to the set containing A, B, C? Now, so let's count we'll count all of the different things that come over to A, B, C. And you can count them by you have 3 positions, right? And you have 3 choices, A, B, or C for this first position. Notice that this is in the first position, this, let's say first position here. This is the first position. You have either A or B or C, so you have 3 choices. Once one of those is chosen, then you only have 2 choices and then 1 choice, right? That's 3 times 2 times 1, that's 3 factorial. So the number of things over here that come over to the set containing A, B, C, this is 3 factorial, otherwise known as 6. Right, 3 factorial, 3 times 2 times 1, that's 6. So to recap, this is 1 over 6 cardinality of P. Oops. Written a lot of betas in my day. I'll add this back in here. Right. Now the cardinality of P, right, we have a formula for that. That's 5 factorial over 5 minus 3 factorial. But as we just said, that 6 is really 3 factorial because we're counting the number of different things that can come over to A, B, C. So that shows you that 6 is actually 3 factorial. And so this is 5 factorial over 3 factorial, 5 minus 3 factorial.